Okay, why don't we begin with a discussion of social cognitive neuropsychology, which Taylor calls social cognitive neuroscience, but it'll be clear in a couple minutes why I like this better. Okay, any piece of behavior, any aspect of mental life can be analyzed at least three different levels of analysis. There's the psychological level, which we've been talking about in this course and which forms the basis for the discipline of psychology, which basically takes the individual mental state as its subject matter. There is the sociocultural level of analysis, which moves up one level from the individual and looks at whole groups of people, institutions, societies, cultures, organizations, whatever, without paying too much attention to the individual members of these groups. And there's the biophysical level of analysis, which looks at brains and other physical substrata of both psychological and sociocultural processes. Now, the way I've drawn this is the way I think it is, which is that psychology and the psychological level of analysis stands in between the sociocultural and the biophysical levels, and in some sense serves to link them in a way that no other science does. And the various subfields of psychology perform different aspects of this linkage. For example, social psychology, and especially the study of social cognition, serves to link the psychological level of analysis, focused on the individual's mental state, with the sociocultural level, which is focused on the social context in which individual thoughts and experiences and actions take place. And cognitive psychology tends to link the psychological level to the biophysical level, because what cognitive psychologists are mostly concerned with are kind of the abstract features of the mind that are purportedly very closely related to how the brain works. Remember, the mind is what the brain does. So we've got a field like cognitive neuroscience, which takes that as its explicit function, to link what goes on in the mind when it comes to cognitive processes like perception and memory and thinking and all of that to what goes on in the brain. The new field, which is now typically called social neuroscience, tries to do exactly the same thing, except to focus on social aspects of cognition, and for that matter, things like emotion and motivation, but to try to figure out what the links are between what's going on at the level of the social mind, social cognition, and what's going on at the level of the brain. Now, let's just do a little quick history here, because I want to lay some foundations. Has been since the 19th century, a broad field in psychology known as physiological psychology, which is based mostly on animal research, not so much human research, which tries to understand the physiological substrates of basic behavioral processes like sensation and motor action. Beginning in the middle part of the 20th century, we began to experience the rise of a new field known as neuropsychology, which is neuropsychology is based on behavioral analysis of brain-damaged patients, and tries to use the behavioral analysis of brain-damaged patients to establish linkages between the particular sites of brain damage and behavioral deficiencies on the part of the patients who suffer that damage. I have 1955 here as the date, because that's the date of the first paper on patient HM, which is really where we can begin to think of neuropsychology as starting. HM, as you all remember, was a patient who had a young man who suffered from intractable epilepsy. As a kind of desperate attempted cure, his surgeons decided to literally carve out those portions of the medial portion of his temporal lobe where his seizures seemed to be arising from. They did that. The treatment was successful in that his seizures pretty much disappeared, but there was a side effect, which was that he lost his memory. He lost the ability to lay down consciously accessible traces of any further experiments, and it was actually the discovery of patient M that got neuropsychology going. There were neuropsychologists before then, but it was the discovery of HM that really started things. And then in 1963, mostly at the instigation of a private foundation, the Sloan Foundation, there began to develop an interdisciplinary field known as neuroscience, which would bring together neurologists, neurophysiologists, biologists, molecular cellular biologists, geneticists, and psychologists to study various aspects of the brain in action. Okay, so if you think about that as the background for the evolution of social neuroscience, first we had neurology. We've had a discipline of neurology in medicine for a couple hundred years, which you could break down into neuroanatomy, the study of structure, and neurophysiology, the study of function. Neurology, which was a medical specialty, then began to be broadened to include PhDs, mere PhDs, who would call themselves neuroscientists. And again, neuroscientific analyses tended to be done at one of three basic levels. Molecular and cellular neuroscience focuses on the individual neuron, what transpires when an action potential starts at the cell body and moves down the axon to the terminal fibers, and also what happens in the synapse between neurons. That's the subject matter for molecular and cell neuroscience. Then there's systems neuroscience, which tries to understand the larger structure of the nervous system, how you get collections of neurons together into nerves and tissues and all of that business. But here you're still doing biology. You're really just focused on how the brain works, how the nervous system works, and how it's structured. It's only when you get to the behavioral level of neuroscience that you begin to think about function, which is to say, what is it that these various parts of the nervous system with their various operating principles do to serve thought and action. And behavioral neuroscience then gets broken up historically into a whole bunch of other fields. Integrative neuroscience, looking at really large pieces of the brain. Cognitive neuroscience, looking at the neural substrates of cognitive functions like perception and memory. We've got a new discipline of affective neuroscience now that looks specifically at emotional processes. Maybe someday soon we'll have cognitive neuroscience, which looks at motivation. We don't have that quite yet. But for our purposes, the most important thing is social neuroscience, which tries to look at the neural connections to social behavior and especially social cognition. So all of this is relatively recent. Back in the 1940s, before anybody thought about neuroscience, the agenda in some respects for neuroscience was set by people like Clifford T. Morgan, very distinguished physiological psychologist, and nobody says. Physiological psychology is the study of the relation between the organism's physiological processes and its behavior. Before this point, people didn't really think too much about this relationship. They just assumed that there was behavior, and they assumed that its basis somehow lay in the brain, but whether because they weren't interested or because the techniques were too primitive, they weren't particularly concerned with linking the two. If you think about the functional behaviorism of B.F. Skinner, Skinner talked about the brain being kind of a black box into which there was stimulus inputs were put and out of which behavioral outputs were extracted. But Skinner and other radical behaviorists argued you didn't have to know anything about how the black box worked. You didn't have to know anything about its structure or its function. All you had to care about was the relationship between stimulus inputs and behavioral outputs. But Morgan argued that you could now begin to study the physiological mechanisms of behavior. Phil Teitelbaum, another distinguished physiological psychologist, made the same point. Physiological psychology is a method for understanding behavior, as well as a set of principles that relate the function and organization of the nervous system to the phenomena of behavior. The agenda is establishing these correlations. When we get to cognitive neuroscience, Mike Gazzaniga, who is generally acknowledged at UC Santa Barbara, generally acknowledged as the founding father of cognitive neuroscience, he coined the term, issued a kind of manifesto for this. He argued that the agenda for cognitive neuroscience is to describe the algorithms that drive structural neural elements into the physiological activity that results in perception and so on. What Gazzaniga was talking about was yet another, everything comes in threes, another three-level analysis of mind and behavior proposed by David Marr, artificial intelligence researcher at MIT, who argued that mostly psychology works at what he called the computational level of analysis, just trying to describe what the phenomena of mind are and how they relate to each other. But Marr was an artificial intelligence researcher. He was interested in creating computer simulations of mental processing, if not getting computers to actually think. And he argued that beyond simply describing what these various mental processes are, the first thing we had to do was to identify the algorithms, the rules that actually generated these various phenomena of psychology. And then finally, we had to understand how they were implemented how these algorithms were implemented in physical structures. For psychology, the physical structure is the physical structure of the mind, the wet meat that is neural tissue. For Marr and other artificial intelligence people, you could just as well look at the physical structure of a computer that tried to perform the same kinds of tests, silicon chips, and so on. So Gazzaniga in 1995 said, look, what we want to do is to understand what these neural elements are, how these algorithms are implemented in the wet tissue of the brain. That was the agenda for cognitive neuroscience. Even more recently, in the third edition of his book, makes much the same point, a little bit more succinctly. Cognitive neuroscience attempts to understand the biological underpinnings of complex cognition. That's what the traditional agenda for cognitive neuroscience has been. To which end, cognitive neuroscientists have developed a large number of different techniques that can be used to trace the connections between what goes on in the mind and what goes on in the brain. There are, first of all, traditional neuropsychological approaches. As we'll see today and again on Wednesday, you can find people with specific brain lesions who seem to have specific deficits in specifically social cognitive functions, and from that kind of evidence say, well, this area where they have a lesion must be important for this psychological function. Traditional neuropsychology has been around at least since the time of HM and is still important. But these days, the queen, or if you will, the king of cognitive neuroscience and social cognitive neuroscience as well, are various techniques of brain imaging. In particular, functional magnetic resonance imaging. There's an fMRI, an MRI machine there, which tries to record the byproducts of neural activity while people are engaged in various kinds of cognitive tasks. There's another technique that's very popular called the study of event-related potentials, where we can record EEG signals from the surface of the cortex. Don't have to use particularly fancy machines for this. And again, look at various signals that are created by the brain while it performs various kinds of tasks. And then every once in a while, you get a chance to do single cell recording. I put this in quotes because it's not always a single cell, but it's a very small cluster of cells, like we saw in the Tian Quiroga study with the Jennifer Aniston neuron and the Halle Berry neuron, where if you're lucky, you can record the activities of very, very, very small clusters of neurons while people are engaged in various kinds of tasks. Complementing brain imaging, which records brain activity while people are performing some kind of task, we have a whole bunch of techniques for brain stimulation, which tries to actually stimulate various parts of the brain and see what effects that stimulation has on mental functioning. Whether it's electrical stimulation, drop an electrode into some brain piece and put a little jolt of electricity into it. Transcranial magnetic stimulation is very popular. We have a big TMS lab here at Berkeley, and now transcranial electrical stimulation as well. These are a whole bunch of techniques, all of which are described in the Fisk and Taylor book, if you're not familiar with them, that can be used to foster the agenda of social cognitive neuroscience, which is to trace various links between what goes on at the cognitive level of analysis, at the psychological level of analysis, and what goes on at the biophysical level of analysis. Fisk and Taylor acknowledge this agenda. Very first edition of their book, in fact, even the second edition of their book, didn't talk about the brain too much at all. But now they've got a big section titled Brains Matter, in which they talk about measures like the ones I just described, opening new doors into the life of the social mind, and allow us to identify distinct social cognitive processes on the basis of distinct neuroscientific processes. Notice what this says: allowing dissociating distinct social cognitive processes on the basis of distinct neuroscientific responses. What that implies, at least in my reading, is that somehow evidence about neural functioning can be used to inform psychological theories at higher levels of analysis. We're not just talking about identifying some cognitive process and then using some brain imaging technique to identify where that process is executed in the brain. We're talking about going in the other direction to identify particular brain operations and use those to somehow shape the writing of psychological theory. This is an aspect of neuroscience which I think ought to be more controversial than it is, and it's what I call the rhetoric of constraint. And what the rhetoric of constraint does basically is say that biological findings constrain psychological theories. Findings at the biophysical level of analysis will constrain what we can say about the mind at higher levels, like the psychological level or the socio-cultural level of analysis. So here again, we have a statement of this from Mike Gazzaniga. Disciplines of cognitive psychology, behavioral neurology, and neuroscience now feed off each other, contributing a new view to the understanding of the mechanism of the mind. That's fine. But then he goes on to say, any computational theory, referring back to Marr here, any computational theory must be sensitive to the real biology of the nervous system, constrained by how the brain actually works. This is a very pithy statement of what I call the doctrine of constraint. And as you might suspect, I'm going to take some time now to try to both show you that this is a serious position in neuroscience and also try to show you that it's wrong. Yes? No, I think what Gazzaniga is saying is the whole is precisely the same as the sum of its parts. That the brain, well, of course, the mind is what the brain does, right? No brain, no mind. That's the basic materialist position of scientific psychology. But he's actually trying to say more than that. What he's trying to say is that if you understand the structure and function of the brain well enough, you can infer what the right theory is from at the psychological level of analysis. From Morgan and Teitelbaum, even early Gazzaniga, on up, the whole idea was, first we describe how the mind works, we get an adequate theory at the psychological level of analysis, and then, once we've invented things like fMRI, then we can figure out how the brain does it. The rhetoric of constraint does something quite different. It says, once we find out how the brain works, then we'll know what a proper psychological theory is. And that, I think, is not quite right. Here is, just so you know that this isn't a straw man, this is work by Stephen Coslin, who's a distinguished cognitive neuroscientist. When you took intro, you all read about Coslin's studies of mental scanning of maps and things like that. He's the guy who did that work. In an early text on cognitive neuroscience, he made a distinction between those psychologists who study the dry mind, that is just behavior, and those who study the wet mind, that is the brain. And he goes on to say, description of mental events is a description of brain function, and facts about the brain are needed to characterize these events. This is another statement of the rhetoric of constraint, that we don't really know what a proper psychological description is unless we know what the proper neurophysiological description is. A very good example of the rhetoric of constraint. Notice that he goes on to kind of draw this analogy to architecture. Although the nature of the materials restricts the kinds of buildings that can be built, it does not characterize their function and design. Nevertheless, the kinds of designs that are feasible depend on the nature of the materials. Skyscrapers cannot be built with only boards and nails, and minds do not arise from just any substrate. Now, that might be right, that minds don't arise from just any substrate. There are people out there who think that you could build a perfectly well-functioning mind with beer cans connected by string. That's not the typical position in psychology. But the fact of the matter is that, yeah, you can't build a skyscraper out of feathers, okay? But the fact that you have bricks and steel and all that doesn't make you build a skyscraper. There's still a lot of different designs you can function. This analogy, I think, is just not quite right. The rhetoric of constraint is extremely popular in neuroscience. Here is Kevin Oxner, a psychologist at Columbia University, and again, Steve Coslin, talking about what they call the cognitive neuroscience triangle. Here we have traditional psychology trying to describe people's various cognitive abilities. Here we have what you might call computational modeling, where you try to figure out what the algorithms are in Mars sense, and then neuroscience, which looks at the physical implementation. But instead of Mars hierarchy, where the computational and algorithmic analyses are followed by the implementational analysis, instead, Oxner and Coslin assert that explanations of cognitive abilities rest on conceptions of how the brain computes. Again, the idea is you got to know how the brain works before you can know how the mind works. Here are two examples of the rhetoric of constraint, specifically in social cognitive neuroscience. John Cacioppo and Gary Bernson, 1992. This is the first paper to use the term social cognitive neuroscience. Assert knowledge of the body and the brain can usefully constrain and inspire concepts and theories of psychological function. Knowledge about the brain constrains psychological theory. Kevin Oxner and Matt Lieberman, psychologist at UCLA, data about the brain began to be used to constrain theories about cognitive processes. These are all statements of this rhetoric of constraint, which is employed by some people in cognitive and social neuroscience to argue that you can't have a proper psychological theory unless you know how the brain works. Well, okay, here's one more. This is from Dan Goleman, who's a popular science writer, but who also happens to hold a PhD in psychology, which just kind of shows you how deep this goes. The neuroscientific findings on social life have the potential to reinvigorate the social and behavioral sciences. In previous pages, Goleman's argued that social behavioral sciences are almost comatose, nothing new has been found in them for a long time, and that neuroscience is going to jazz things up. And then as an example, the basic assumption of economics, for example, have been challenged by the emerging neuroeconomics, which studies the brain during decision-making. Its findings have shaken standard thinking in economics. And for those of you who know your history of psychology, you know that that simply is not true. The people who shook up standard thinking in economics were Danny Kahneman and Amos Tversky, and they did it with paper and pencil questionnaires. Okay? They did it with studies that showed the use of judgment heuristics like representativeness and availability and anchoring and adjustment and all of that. They never looked at a brain. They never used an fMRI machine. They never did anything. They got the Nobel Prize. Well, Kahneman did. Tversky was deceased and he was not eligible. Not the people who are studying the brain. So if that's Goleman's example of how social psychology can make progress, it's completely wrong-headed because what he considers to be his best example is not a good example. Okay, here's my example. Going back to the foundings of neuropsychology and explaining the deficit in memory that results when people like patient HM suffer lesions in the hippocampus. The fact is, HM had lesions in his hippocampus and in other areas of the medial portion of the temporal lobe, parahippocampal gyrus, and so on. And after that, he had difficulty with memory. He suffered an anterograde amnesia. But what you want to do is, well, why does that happen? What does hippocampal damage do to screw up memory, to create an anterograde amnesia? If you trace the history of attempts to explain the relationship between hippocampus and memory, what you find is that the various explanations that have been offered track precisely developments in the theory of human memory that have absolutely nothing to do with any kind of analysis of the brain. So when Scoville and Milner published their very first study of HM, what they said was, he seems to have a problem with learning. Because in 1955, that's what psychology was all about. It was about learning. Okay? Then, around the late 1960s, when people like Atkinson and Shiffrin began to make a distinction between two kinds of